26. Sorting three groups. So for this problem, we are giving integer nums. Each of the elements in nums is just 1, 2, or 3. In each operation, you can remove an element from the nums. So we're going to return the minimum number of operations to make nums non-decreasing. So what is the meaning of non-decreasing? It means it's going to be in increase order, but some numbers can be equal. So this is something like non-decreasing. So if we are going to keep the nums in non-decreasing order, actually this is the longest increasing subsequence problem. We can solve it by using nlogn time. This is I think this is either way, or we can use n squared time. But for this time, we're gonna analyze how to solve it in nlogn time, and after that, we're gonna use a better idea, which is on time complexity. Yeah, which is a little bit difficult to think, but it is a follow-up question because we need to solve it with on time complexity. Yeah. So first of all, let's just solve it in nlogn time. So this is the greedy idea. So we're going to prepare an empty array. So the idea is that we're going to prepare an empty array. So this is going to be the f array, and we're going to put numbers one by one. From the beginning, it is empty, so we're going to put the number 2 inside, and then it is 1, so we're going to update this 2 with 1, and then for the next number 3, we're going to put it after 1, it's going to be 3, and then it is 2, so we're going to update this 3 with 2, because 2 is more than 1, so we're going to put 2 here. Yeah. So currently the longest increasing subsequence is 2, and for the next we're going to put a 1, as 1 going to be more than and equal to 1, so we're going to put 1 here. Yeah. So the longest increasing subsequence is going to be 2, and the final answer is going to be the length of the nums array, so 5 minus 2. It's going to be 3 operations. Yeah. So this is the first idea, nlogn time. Yeah. So another idea is on time. This idea is a little bit difficult to think, but this is the DP solution. So we're going to prepare an F array. So the F array, from the beginning, we're going to initialize it. The length of the F array is going to be 4, and the index is going to be 0, 1, 2, 3. So the meaning of the index is how many numbers, the meaning is so the meaning is what is the longest increasing subsequence adding with number 1, adding with number 2, or adding with number 3. So this is the meaning. So for example, for the first number 2, so this is a number 2. So we're gonna check it with this number 2 here. Yeah, because basically for number 2, we're gonna find all the possible numbers which is gonna be more than and equal to 2. So this means 0, 1, 1 and 2. So we're gonna check it from here. This is 0, 0, 0. So the maximum of those 3 numbers are gonna be 0. So 0 plus 1, it's going to be 1. So for here, it's going to be updated to 1. And then we're going to check the next number, which is 1. So for 1, we're going to check the maximum number of from index 0 to 1. Basically, this index 0, we never use it. So we're going to check the index 1. So it is 0. So it's going to be 0 plus 1. So it's going to be updated to 1. And then for the next number 3. 3 is here. We're going to check the maximum number of f123, so 110, so the maximum number is 1, so 1 plus 1, so for 3 it's going to be updated to 2, and for the next number 2, it's going to be here, it's going to be the maximum of 1 and 1 plus 1, it's going to be 2 here, and for the next, this is 1, so it's going to be the maximum of 1 plus 1, it's going to be 2, so the final answer going to be the length of the nums array minus the maximum of the F array. It's going to be 2, so it's going to be 3. Yeah, as you can see, those two solutions are really I mean, basically the on square is really easy to think about, but the nlogn time, basically if you solve a lot of Leetcode problem, you can also think about it. But this on time, yeah, it's just another way, another dynamic programming idea, because we only need to have 3 numbers. So this is why we can define this kind of F array. Yeah. Now let's just use the nlogn time to solve it first. So for inside the num, so we're gonna prepare the index. It's gonna be, this time it's gonna be bisect right, because it is not strictly increasing. So for this F and if I equal to length of the array, So f gonna append this number, else we're gonna update it at index I, so fi gonna equal to n. So finally we're gonna return the length of the nums minus the length of the f array. So now let me just submit it. Yeah, let me just run it to check. So what is wrong? Oh, so this is a bisect. This is a typo. Now as you can see it works. Now let me just submit it. Yeah, as you can see the pass for all testing cases, and I think the speed is okay. This is nlogn time. Now we're gonna change a little bit to make on time. So here for the function f, as this gonna be a DP problem. So it's gonna be 0 times 4. So this meaning, so the meaning is that from the index 1 to 3, it means what's gonna be the longest increase in subsequence adding with number 1, adding with number 2, or adding with number 3. And similarly, we still need to check for numbers for n inside of the nums. So we're gonna update it at this number. So fn gonna be the maximum of f1 to n plus 1, and yeah, that's it. And finally, we just need to return the length of the nums minus the length of the f array. Now let me just what is wrong? Yeah, maybe let's just include it. Oh, there's something wrong. Yeah, let me just check what is I think this is the max of f array. I used the length, definitely it is wrong. Now let me just run it. So here gonna be 1 to n. Oh, it didn't work. This is n plus 1. I did something wrong. It's gonna be 1 to n plus 1, definitely, because we need to include this number n. Yeah. Now let me just run it and submit it. As you can see, it passed for all testing cases, and this is the on time complexity. Basically, we can ignore about this max because the length of the f array is only 4, so this is why we can ignore it. I think that's all about it. Thanks for watching. See you next time.